Hello there, and welcome to Step 5 in the Gliomorph Toolkit, 3D quantification of glial cell morphology. So far in our journey, we've carried out the visualization and pre-processing steps, including the subregion tool and splitting the channels. We've just now completed the segmentation step, binarizing our images to delineate the milliglia from the background. We will now carry out the quantification step, which will provide us with numerical values to assess the morphology of milliglia. So firstly, from the segmented TIFF images, we can coalesce the slices to recreate a 3D version of the milliglia. And then from this, we can measure these variables. So we can measure image heights, the total height of the image, milliglia heights, the distance over which the milliglia processes extend, the volume of the milliglia, and the percentage cover, the percentage of the image volume occupied by the milliglia. Another of the outputs of this quantification step is the thickness of the milliglia. We can assess this by creating an EDM, a Euclidean Distance Map, as shown here. In this image, the greater the intensity, as shown here along the bottom, the thicker the area. For instance, the centre of the milliglia cell bodies are thickest, whilst the processes are thinnest. From this EDM, we can calculate the average thickness of the milliglia processes. Another output of this quantification step is this surface map. This image here gives us an idea of the membrane of the milliglia, with the different colours demonstrating the position within the z-axis. In other words, the depth within the stack. From this image, we can calculate the surface area of the milliglia, as well as the surface area to volume ratio. Now, as well as all these other measurements we've done so far, we will also extract the 3D skeleton via a process called 3D thinning, or iterative thinning. This process essentially strips off layers from the 3D structure of the milliglia, much like stripping layers off an onion, until there is a skeleton structure remaining. From this skeleton, we can determine the length of the skeleton, the number of junctions, the number of endpoints, and the average branch length. Now, in the physiological states, the milliglia performs its functions by contacting many cells through its diffuse input processes. These measurements here allow us to understand the structure of the milliglia, and in doing so, give us an idea of how well it can make contact with other cells to perform its function. Now, the final output of quantification is zonation. So we've completed the zonation tool for the original image, as we have here. Now the quantification macro will provide us with zonation profiles for the segmentation and skeleton images. So just to recap what the zonation profile tells us, the areas where it is brighter indicate there is a greater signal intensity in that region. For instance, here it is bright because this relates to the area with the cell bodies. The purpose of the zonation profile is to provide an apicobasal profile of the milliglial cell to delineate the different layers within the retina. For instance, here we can see a slightly brighter area corresponding to the inner plexiform layer. And again, here we have a zonation profile on the right. Here are some areas that are brighter, corresponding to greater signal intensity. We can also show this information in a graphical form, as shown on the left. So for instance, here we start off at around 60, 70, as shown here on the left in the graph. This then decreases, as shown in the zonation profile by this black area here. And again, in this graph, you can see two peaks, which correspond to these brighter areas on the zonation profile. So in other words, this graph is just another way of showing the information from this zonation profile. And so we've discussed some of the outputs of the quantification step. Now let's move on to how to do the step itself. So if we go into Gliomorph main, and then macros, and we go to step A, quantification tool, drag and drop that over onto Fiji, and you'll come to this screen. Press run, and select the file with the segmented TIFF images. It's likely to be called TH. The macro is now running. Okay, so the macro is now finished, and I've closed the files down. I just want to show what output we should have. So if we go to the output file, which should be th. So originally we started off with these three segmented images and the maximum intensity projections, and these are the output files. So if we start off with quantification results, that should show the volume of the milliglia, percentage cover, surface volume, and the thickness. Skeleton statistics Excel file should show all these variables. So it should show the total length, the maximum branch length, the mean branch length, number of junctions, and number of endpoints in particular. Okay, and let's have a look at the other folders as well. So out EDM, Euclidean Distance Map. We should have the EDMs, which should look like this. Again, with the color showing the thickness. And we have maximum intensity projections of those. And now back to the original file. We have out scale as well. So this is a skeleton image. We have the zonation profile of the skeleton image, which you can see if I zoom in. And we also have Excel files showing the signal intensity. And then within that file as well, we also have maximum intensity projections of the skeleton. Back to the original file. We also have out surf, which shows images of the edges. And again, we have maximum intensity projections of those. And then finally, we have out zone. So this is the zonation profile of the segmented images. And again, if I zoom in, you can see different colors. So that's all the outcomes from the quantification step of gliomorph. Thank you so much for listening, and I hope you find gliomorph useful.